Welcome back. Until now, we've focused on scenarios where everything runs smoothly, but real-world applications often encounter errors, such as failed API requests or missing database resources. NestJS provides several methods to manage errors and send appropriate user-friendly response messages, such as throwing an HTTP exception or even creating interceptors and utilizing exception filters, which I'll be talking about in later videos. Let's go to our product controller. And by the way, let's change our route from product to products to align with RESTful API best practices. Using plural nouns for resource collections clearly indicates that the endpoint deals with a collection of products, enhancing consistency and predictability in our API design. And while we are at it, let's change our file names as well. Let's start by the product service file and change it to products and update imports for this file and change its class name to product service. Next, let's go to the test file for this service and change its name and update product service here. Then let's go to the controller file and update its imports as well. And after that, let's update the class name here and update the product service. And after that, let's go to the corresponding test file and change its name, update the test file for new products controller. Then let's go to product module and change it to products module and update its imports. And let's change the product module to products module and update the products controller and product services here. After that, let's go to app module and update the product modules here. And finally, let's change the file name for our products module and update its imports. And let's see if everything's working right now. I will stop the application and run it again, and everything works. Let's go to Postman and send a GET request to /products endpoint, and it looks like everything works. We see a few problems here, and we can get rid of them by deleting this build directory. And we can remove it like this and start our application again. This usually works, but if it didn't work for you like mine, you can restart the VS Code. After restarting your VS Code, you can start the application again and problems are gone. And if you still have a problem, I'm going to push these changes to a new branch called naming changes. You can clone the repo from the link in the description and pull it from the branch. Let's go back to our original topic. Let's go to our service and let's check out this method, get product by ID. Let's say if a user tried to get a product that doesn't exist in our database, we want to throw an error. First, assign the return value from the products.find function to a variable. Next, check if product is undefined. If it is, we throw an HTTP exception. And the HTTP exception constructor takes two parameters. One a string for the error message and the other the status code. Let's write product with ID not found. And let's use HTTP status enum imported from the NestJS common. Not found. And if the product exists, let's return it. Let's go to Postman and make a GET request to product/1. We get a product, and make a GET request to product/2, and we see status code 404 not found and with our error message. Okay, also NestJS includes an exception layer that automatically catches unhandled exceptions and returns suitable responses. For example, if you throw a random error here, and if we hit the endpoint again, Nest will intercept this and return a 500 internal service error. And if we check the terminal, we see unexpected error here. This built-in exception handling is very useful for catching deeply nested errors in our code or in third-party libraries. It ensures that all errors are caught and handled. Okay, I will talk more about exception filters in later videos. Now let's talk about data transfer objects or DTOs. Think of DTOs as a ways to package data and send it from one part of our application to another or send it between systems. They help us define what our input and output data should look like. For example, with our post request, DTOs let us define the structure of the incoming request body, making our code cleaner and more reliable. So far, we used the body decorator in our post and patch endpoints, but we haven't defined what the payload should look like. This is where DTOs comes in. They allows us to explicitly define the shape of our data, ensuring we know exactly what we're working with. Let's generate a DTO for our post endpoint in the products controller. Open your terminal and run nest generate class products/DTO/ create product.DTO with a no spec flag to avoid generating a test class. And we include .DTO in the file name as a best practice, making it easy to identify as a DTO. And we put our new DTO file in a dedicated DTO directory within our products folder to keep things organized. This is a great habit for other DTOs, interfaces, entities, and similar items. Keeping everything grouped within their associated module makes the code cleaner and easier to manage. And create product DTO is just a class. So let's go our entity and see what we are using when we are creating a product. Let's copy and paste these fields into our DTO. And we can delete the ID since we don't need an ID field because that's usually generated by the database itself, and we will set it up later. Okay, this DTO defines the shape of the data we expect when we are creating a new product. Now we need to update our post request to use this DTO. Let's change this body name to create product DTO and set it to type create product DTO. And let's change the body instance here to create product DTO. Okay, this gives us type safety, ensuring we know exactly what they expect in the payload. Next, we need to keep our data immutable. It's a best practice to mark DTO properties as read-only. Okay, for now, our entity and our DTO looks very similar. We are going to visit here again when we start using a real database in later videos. Now let's create another DTO for our patch request. Hit the up arrow and let's change this create product to update product. We'll copy properties from create product DTO to update product DTO, but make them optional. Since this is a patch request DTO, we don't need all the fields. In TypeScript, we can make properties optional with just adding a question mark before the colon. And by the way, this is actually a repetitiveness, and we will talk about avoiding these kind of repetitiveness in a few minutes. Now let's update our patch request method signature to use this new DTO, replace body with update product DTO, and set type of it. And let's change this body instance to update product DTO. Now our patch request can handle any combination of properties, perfect for partial updates. So DTOs are simple objects that define the structure of our data without containing any business logic. They are incredibly useful for ensuring type safety and clarity in our API's requests. Okay, but how do we validate these requests automatically? It's a best practice in any backend to validate incoming data automatically. Imagine we have various clients making requests to our API. We need a way to ensure that the data they send meets our requirements, like having all required fields and the correct data types. NestJS makes this easy with the validation pipe. Let's open our main TS file and let's write app.use global pipes and pass new validation pipe. This ensures that all incoming requests are validated according to the rules we define in our DTOs. But before we dive into adding validation rules, we need to install a few packages. In your terminal, enter in npm I class validator and class transformer. These packages help us define and transform our DTOs with validation rules. When they are installed, let's start by adding validation rules to our created product DTO. Let's import isString and isNumber decorators from the class validator and apply it to our properties. Here is string ensures that the name is string, is number ensures price is number, while is string each true ensures that tags in an array of strings and making them required. With these decorators in place, if a request hits our endpoint with invalid data, for example, missing required fields or incorrect types, NestJS automatically responds with a 400 bad request status and provides detailed error messages. This gives us immediate feedback on what's wrong with the request payload. And this should be not this number, but a string. And let's go to our product controller and remove the name from here. And let's go to Postman and test our new validation rules. Let's send a post request to the /products endpoint with a body like, with just a name, string, and let's call it bag. And send the request. And we see price must be a number, and each value in tags must be a string. And the status code 400 bad request. Now let's add price and tags, but let's add flags as numbers and send the request again, and we see each value in tags must be a string. Perfect. And let's fix it and send again, and we got a 201 created status code. Perfect. Now let's go our update product DTO and improve it. We did use redundant code here, and we can avoid it. Instead of manually copying properties from create product DTO, we can use partial type. First, let's install it by running npm I at NestJS map types. After the installation, let's delete all the properties in update product DTO and extend partial type here. And let's import partial type. And this partial type is expecting a type to be passed. By extending partial type, create product DTO, all properties in update product DTO become optional. Inheriting validation rules from create product DTO, this means we maintain type safety while allowing partial updates in our patch request and avoid duplicate code. Alright, let's dive into some more features of the validation pipeline. Let's go to our main TS file. One of the neat things validation pipe can do is whitelisting. This means we can specify which properties are allowed to be received by our methods, and any extras are automatically filtered out. Let's say you want to ensure that only specific properties defined in your DTO are accepted when creating a new product. Let's pass in an object of the validation pipe with the key values whitelist true. Setting whitelist true in validation pipe ensures that any unexpected properties sent by the client are stripped out. This keeps our data clean and in line with what our application expects. To see this in action, let's go to our product service and make sure to return the DTO itself back to the client in our create method. Let's go to Postman and send a post request with the properties like name, price, and tags from our DTO. But let's also include an additional property that isn't part of our DTO, like count 5. When you send this request and inspect the response, you'll notice that only the properties defined in your DTO, which are name, price, and tags, are coming back to you. The count property, which isn't part of the DTO, is automatically removed by the validation pipeline's whitelist feature. Now, if you want to enforce even stricter rules to stop processing requests that contains non-whitelisting properties, we can add forbid non-whitelisted to true. This property, in combination with whitelist, will enable this functionality. If you resend the previous request with the count property included, you'll now receive a 400 bad request from the service. And this error message will inform you that the count property is not allowed, giving you clear feedback on what went wrong. This feature not only ensures data integrity and security, but also make your API more robust and easier to maintain. It's a powerful tool to handle input validation seamlessly. Okay, now let's talk about another feature of the validation pipe: automatically transforming payloads into DTO instances and handling type conversions. Payloads coming in over the network are plain JavaScript objects. The validation pipe can automatically transform payloads to be objects according to their DTO classes. First, let's make a test. Let's go to our product controller and add a console log in our post request, and let's log create product DTO, instance of create product DTO. And let's hit the post endpoint, removing count property here. And we see false in our terminal. This means that although the payload looks right, it's not recognized as an actual instance of create product DTO. To fix this and automatically transform incoming data into the correct DTO instances, we turn the validation pipe and set transform to true. This powerful tool can handle this transformation globally across the entire application. Now when we try the post request again and check our console, we'll see that now logs true, confirming that validation pipe successfully transformed our payload into the expected DTO instance. And this feature also handles primitive type conversions like booleans and numbers. In our getProduct method, let's say we expect a number, but it comes in as a string by default. And we need to update the expecting service. And also we need to update the patch request because it's using the same method inside. Let's turn this to number and turn this to number as well. As you know, TypeScript checking ensures that the types of parameters and variables match across methods. Okay, even though path parameters are string by default, validation pipe will automatically convert them to the specified type, number in this case, when transform true is enabled. Now to test this, let's go to product service and remove the error we put here. And go to Postman and make a get request to product/1. And we can see that the ID parameter will correctly be interpreted as a number. Alright, that's it for this video. In the next video, we will connect our application to a real database. So hit sub, hit like, hang out in the comments. That's been it for this one. Thanks for watching. Catch you guys in the next one.